Being able to tell at a glance the value of a resistor is a handy skill to have. A resistor has colored bands. Each band represents a number, with the exception of the final value, which represents the tolerance of the resistor from the value it's labeled as. There's a mnemonic for that, and that is, bad boys race our young girls, but violet generally wins. The tolerance will be either gold for 5% or silver for 10%. The tolerance gives the accepted deviation from the resistance given by the value and magnitude bands. Resistors will either have 5 bands or 4 bands. In either case, the last band is tolerance, the second to last band is magnitude, and the preceding bands give the value. Let's look at an example. My first 3 bands are value bands, so they're going to give me 3 numbers. The fourth band is a magnitude band, so it's going to be 10 raised to some number. And the fifth band is a tolerance, which gives me the allowed deviance. Each color in the value bands corresponds to a number. Red corresponds to 2. Black corresponds to 0. This gives me a base value of 200. Next I have the magnitude band, which I multiply the value by. So I get 10 raised to orange, which is 3, giving me 200 times 10 to the third power. That means that the base value is 200 times 10 to the third ohms, or 200 kiloohms. Finally, we multiply 200 kiloohms times 5% to get the allowed deviation from 200 kiloohms. So we get 10 kiloohms as our allowed deviance, which gives us 200 plus or minus 10 kiloohms as the expected value of this resistor. That about covers it. It can be handy to remember all this. If you're working with something that needs a very precise resistance, you're likely to be working with precision resistors, which will actually have their value and their tolerance stamped directly on them rather than a color code.